Hello and welcome to this video on IPv4 addresses. So in this video, we're going to be looking more at the different terminology that goes with IPv4 addresses, as well as some of the different things we'll need to know about the pieces of an IPv4 address. At this point, hopefully you've already looked at conversions between decimal to binary and binary to decimal, because that could be very helpful for your understanding here. We're not going to be doing calculating in this video, but it'll give you a good idea of some of the pieces we're working with. So when we look at an IPv4 address, for example, 192.168.10.8, okay, we usually write it in this form. So in this format, we have 4 octets. So each one of these pieces is called an octet. And it's called an octet because it can be represented in exactly 8 bits. So 192 in 8 bits is 11000000. I put this space here because I think it's easier to read, but it's not necessary. Okay, it's just so that it's easier to read. I like the little 4-bit sections. But this whole piece together forms the octet 192. So when we're looking at binary notation of this value, we are looking at writing it in, into 4 octets, or 32 total bits, because we have 4 times 8 bits gives us a total of 32 bits. So here we have the number 168, here we have the number 10, and here we have the number 8. So in these cases we have 32 bits, so 32 bits, very crucial number here for IPv4 addresses, and we have it written in binary notation here, where we can actually see the binary digits of each of those bits. And we have it written here in what's called dotted decimal. The name dotted decimal simply comes from the fact that the decimal values are separated. The decimal values are separated by dots, and each value is itself a decimal value. So that means it's a base 10 value number, the number system we're used to working with. So that's what we're looking at when we look at dotted decimal, binary notation, 32 bits, and an octet. The other thing that you should know about IPv4 addresses is part of the address represents the network and part of the address represents the host. So not unlike if you were delivering mail and you would want to, say, find the street the house was on and then look for the house itself. Or if you were going over to a friend's house, you find the neighborhood, then you find the street, then you find the house. We're always going to look for the network first. Not us, but networking devices will look for the network first, and then they will look for the host. So once they find the network it's on, then they go to the host that it's available through. So when we're looking at an IPv4 address, such as the 192.168.10.8 address, part of that would be a network and part of that would be a host. Now, a common one that we deal with is called a /24 network. A /24 network means that the first 24 bits are network bits. So the first 24 bits are network bits. What does that mean? Well, it means that if you write the address in binary, you would have 8 bits here, 8 bits here, so we're at a total of 16 bits. And then we would have another 8 bits here, leading us to a total of 24 bits. So if we separate this address right on that dotted decimal line, we'll see that we have 24 bits over on this side, and we have, spelling error. So we have 24 bits over on this side, and we have 8 bits on this side. If we were to add those together, we would get our total of 32 bits, but as you can see here, we have that 24-bit / notation. Now, when we're looking at network and host portions, the network always comes first, and the host always comes last. Taking the time to write this out because it's very important that you remember that the first portion of the address is the network and the last portion is the host. Now, it's not always 24 bits are network and 8 bits are host. It can be lots of different combinations. If we were to write this address as a 192.168. I don't remember what it was, 10.8/16 network, we would be splitting it right in the middle. If we were to write this address as 192.168.10.8/8 bits, we would be separating it after the first octet. So we have a /24, /16, and a /8. Now these three address spaces, specifically the /24, the /16, and the /8, line up perfectly on the dots. So they line up perfectly with octets. And we call these class full addresses. So these are class full addresses. As we say in class, they line up on the dot, so they're nice and classy. They're perfectly in line. They don't go into other people's space. They're nice and classy. We can also do what we call class list addresses. There's nothing actually bad about these addresses. They just don't line up on the dots. So something, for example, if we had let's say 192.168.10. And I'm going to just write the last bit in binary here. So the 8. Oops. Probably should write it fully in binary, not decimal. So we're going to write the 8 in binary here. If we were to say split this address, if we were to say split this address here, what we would find is that we had 25 bits here, and we have 7 bits here. So in this case, it's a /25 network. In the same way, we could do 192.168.10.8 as a, if we separated the network, say here, now we're borrowing 4 bits, so 1, 2, 3, 4. So we have 24 plus 4 gives us 28 bits on this side, and only 4 bits left on this side, which gives us a total of a /28 network. So you'll notice that always the number of network bits is the same as the / notation. This can also be referred to as prefix notation, and it just indicates how many bits are network bits. Just so you're aware, I'm picking on 192.168.10.8 because I've already converted it to binary, so it's a little bit easier. But you could easily do this with any address. You could do 10.10.10.1, and you could separate it wherever you wanted. If you wanted to, at the beginning, write this in binary as 0001010 dot. This is going to be a tricky one as binary, so maybe or as binary and decimal. So I'm going to write the whole thing out as binary so that you're not confused by the fact that the number 10 in base 10 has 1s and 0s, and all of the numbers in binary have 1s and 0s. Okay, so I've written it out in full binary notation. So if we wanted to split it, even right here, we could. It would be a /1 network. It's not a thing that you'll ever see in networking. If we wanted to split it right here, this might be a little bit more common. That would be a /9 network. You're likely not going to see that in a local area network because it's a very large network. If we wanted to split it here, right in the middle here, now we have, it's not quite in the middle, so we have 8, oh, ran out of space there, 8, and then here we have 3, so 8 plus 8 plus 3 gives us 16, 17, 18, 19 network bits. So we have a /19 notation. So all I'm saying is that this / number in your prefix represents how many bits belong to the network, and we can always calculate it just by counting the number of network bits. Now, the way you've normally seen networks written up to this point has been through subnet masks. So something like 255.255.255.0. Now that's the equivalent of a /24 network. You've likely heard me say that before, but we're going to look at how you actually find out that's the equivalent of a /24 network. So let's go back to our 192.168.10.8 network that we had before. So we had 192.168.10.8. Oops, got a little ahead of myself there. Okay, so this is our 192.168.10.8 network. Okay, so when we're looking at this one, we're looking at /24. We know we're going to be looking at this, but we're not going to quite do that just yet. This is our network address, or this is our, device address. So let's call this a host address. We know we're eventually going to want to find where our host is, but we also need to figure out where our network is first. We want to find the street before we try to find the house. So we use the subnet mask to calculate what the network address is. So the subnet mask, 255.255.255.0, we're going to just write in binary underneath. Now 255 is a nice 8-bit number because it's exactly 7 ones. There's no zeros. 0, on the other hand, is all zeros, no ones. So what you'll find with a subnet address is that all of the bits that are in the network portion are 1, and then the network splits, and all of the bits after that are 0. The 0 bits are the host, and the 1 bits are the network. So the network always goes all ones, then all zeros. It's never 1, 0, 1. It's always all ones, then all zeros. So when we calculate using a subnet address, what we're going to do is we're going to do a logical AND, which means if we have 1 and 1, we're going to get a 1. So 1 and 1 gives us 1, 1 and 1 gives us 1, 0 and 1 gives us 0, 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 dot. And we're going to continue this process all the way through. 1 and 1 gives us 1, 0 and 1 gives us 0, 1 and 1 gives us 1, 0 and 1 gives us 0. So what you're seeing is the only time that you're going to get a 1 in the network address is when both values are 1s. If there's a 1 in the host or a 1 in the subnet, but not in both, we don't get it. So think about if you were told that if you passed your class and your brother passed your class, your parents would take you to Disneyland. You work really hard all term and you pass your class, but your brother doesn't pass his class. Do you get to go to Disneyland? No, because your parents said and. They said you and your brother have to pass. So if your brother works really hard and he passes, but you don't work quite as hard and you don't pass, do you get to go to Disneyland? No, because you didn't pass, but your brother did, and your parents said and. In an and case, both things have to be true. And here we're saying the subnet mask and the network address have to be true. They both have to be 1s. So what you'll find is that we get the same address essentially for the network portion. These bits are the same as these bits. But then for the host portion, we have all zeros. So this is what we call a network address. Maybe I won't write that there. That may confuse you guys. So in our path to find 192.168.0.8, when we're networking traffic, we're going to have to first find this network address here. So we'll just quickly convert that back to decimal. It gives us 192.168.10.0. So that's our network address. So in our path to find 192.168.10.8, we're first going to have to go to the network 192.168.10.0. So that's essentially what we're doing when we look at network addresses, host addresses, binary. I'll make another video where there's lots of examples and you can practice these conversions. But for now, what's crucial is that you know the network portion of the address comes first, the host portion comes second. The Prefix notation. Let me just grab another highlighter color here. Prefix notation. So a /24, a /19, /8, /16, etc. That it represents how many network bits there are. A subnet mask also represents how many network bits there are because all of the ones belong to the network and all of the zeros belong to the host. Back to the beginning, the other thing that we covered here was that classful addresses are nice and classy and line up right on the decimals. Oh, that one wasn't a decimal. And that classless addresses, so classless addresses can line up somewhere in the middle. Going back to the very beginning, we're going to look at IPv4 addresses have 32 bits. They can be written in binary notation. They can be written in dotted decimal notation. And each group of 8 bits is called an octet.